In this video lesson, we're going to continue to explore Grasshopper in Rhino, and I'm continuing here to explore the various tutorial files. We arrived to the sixth, so it's going to be the sixth lesson. I'm going to use the sixth tutorial file, and we're going to start by exploring this, and then we're going to create something next. So I'm working with the basic stuff yet, so let's analyze this and do some really basic operations. So we find here a series of points, and these points define a Nurbs. So let's read a little bit more carefully what we see. So here in the parameters, you can see there is a V, which stands for vertices, and this defines the control points of these Nurbs. Nurbs can be created through control vertices or through interpolation points. The next one is going to be the degree of the curve. So how curvy is this curve? And this is now not defined by anything, so it's using a default value. But it's also suggesting us that we can use an integer. So we can just click and drag or just click with the left mouse and put an integer in there. Now, when we create the integer, we can see that on the suggestions given by the widgets on here, where it says that we can put a point, we can put a number, or we can put a list. Now, these are different inputs, but we can use some of these. So I'm going to use a number. This is not necessary every time. It's just, a way you can do it. There is no one way, but there you have like multiple ways you can do this. So I'm going to plug the number inside the integer. Nothing is happening and everything stopped because it's becoming orange. So there must be a problem. And if I want to see which the problem is, I need to go up here in this little like pop-up message. And it says that it's failing to collect any data. So there isn't data here. There is some missing information we need to proceed to finish this visual scripting. And also it's gonna tell you usually pretty detailed information about this. Also, you can right click and see the runtime warnings in here. So it's saying that a parameter num failed to collect any data. So I'm gonna go down here and set a number because this is empty. This is the problem. Okay, so it doesn't contain anything that can be used to generate our geometry. And I'm gonna type like 7. Now 7 in this case is the degree of the curve. So if the curve has like 0 degree, it cannot happen. It cannot be. So we need to put something in there. And also we can use a number slider or a control knob. So or a list. Now if I put a list inside the number, that one is gonna override the previous and also override the entire number. So if I put like 4 here, that's gonna override the num and it's gonna override the integer, which is gonna go inside the degree. So again, there are many ways you can do this. Now, one curious thing, if I click on edit, I can edit the values here and I can insert more. So I can put a formula, I can put a straight number, etc., etc. So there's always some hint or tip that you can find hidden here and there. And if I put this to 1, you can see this is not going to be a curve anymore. It's going to be basically you can see here like straight, a series of lines, series of straight lines with straight corners. So as soon as I increase this, it's going to make it more and more smooth. So it's basically like the smoothness of the corners, which are defined by the points or the vertices. And this is only half shape as is suggested by the group tag. And one final thing here, the P is, if we roll over as usual, is the periodicity or periodic, or essentially if it's closed or open curve. And this is by default is false. Now if we put a Boolean input, I can plug this inside here, I can double click and make this true. So if it's true, a periodic curve means, or a periodic Nurbs means that it's going to be closed. And false, it means it's going to be open. So is cyclic or not. So it's a toggle for the cyclic feature of a curve, and in the specific of a Nurbs, and more specific of a control vertex curve Nurbs curve. Now, if I click on the group, I can, well, we saw that we can change the way it's displayed, but also we can change the name. So you can customize this. You can call this like half closed shape if you want. Okay, and also change the color as we saw before. So what it's doing right now, in this tutorial, is basically doubling up, copying that Nurbs curve and mirroring it. So it's creating like one half and then the other half by using the mirror. And that's a great thing when you have symmetrical objects or shapes or whatever. It's to create a mirror copy. So you can just work on one and the other side will be automatically defined. And here we have geometry, G, and then P, a plane. So we can create a plane, or we can establish a work plane or a plane where that is gonna be the mirror plane basically. And in this case, it's visible in there. So that's the work plane used for this mirroring. Okay, so if we go up here in the ribbon, we can start to see how the Grasshopper application is thinking. So it needs geometry, and sometimes you have primitives in here, or integers, numbers, points, curves, etc., etc. It needs inputs, but also you have other ribbons to create stuff right away, and also to put some mathematical expressions and formulas and vectors, and then you have curves. So in the curves, this is where you're going to find everything about creating curves, which also can be lines, because in Rhino, lines and straight lines and curves are always defined curves. So here you have like a fit line, which we already saw in another lesson, which is creating a line through points, and then you have like simple lines. And then here in the splines section, this is where you can create the splines. So SP lines are curves. Essentially, well, they can become curves or they cannot be curved, like we just saw by changing the degree. So let's see the interpolation curve. Now in Rhino, we have these two main types of curves. One is the interpolation, and the other one is the control vertices. Now in the interpolation curve, the vertices are, or the points are inside the curve. And I can use the same points that we have here, which goes also in the control vertices. And so you can see that now the points are inside this curve. So same exact points or vertices we are using, but we have two different results if we plug this into an interpolation Nurbs curve or a control vertices Nurbs curve. Okay, then I can change also the position of the points to see what's happening with the two curves. Now this is not really visible. I'm gonna change the display, because this is like gray on gray, so I don't really see it too much, but we can definitely see the points. So I want to show you that we can use the point. Now something happened here when I move this point near the axis. The circles that were inside that shape, they disappear, and so probably we need a closed shape here to have those circles inside, otherwise we lose like the boundary. So if I toggle on the Boolean that we created, you can see now we have two cyclic, so two closed shapes mirrored. And if I let me go all the way here, you can see the circles inside. So I'm guessing we need a closed shape to display those circles inside that shape. So that's let's say array of circles. Okay, so well, there's something problematic with that point, because you know, that thing that's disappear. So how we do manage this? So we right click on the point and go to manage point collection, and this is a way you can enter and know more about the data contained in this node, and also how we can manage it. So if this one here is the last one, and you can see it's not perfectly on the 0x or x equals 0, and probably that's what's determining the problem, because